Hello and welcome to helpyourmath.com. In this video, we're going to analyze arguments using truth tables. And in this video, we're going to look at actual English sentences and have to convert them into logic form. So if you need to watch the video where we just look at logic form and analyzing those arguments, you might want to do that now because I will assume that you know the terminology and whatnot. Okay, let's get started. First, what we have to do is we have to take the English sentences and turn them into symbols. Right? So we've done this before where we've practiced using the conjunction, the disjunction, the conditional, the negation. We have our simple sentences. So we want to make sure that we assign a variable to each simple statement, and then we will go from there to construct the compound statements. The only thing we have to watch out for is if the sentence uses a universal quantifier. If it does, we need to rewrite the sentence as a conditional statement. So we're going to continue to go in English. That way we can convert it into symbols, right? Because we don't have if it says all monkeys, we don't have a thing for all, not in logic. So for example, if we have all squares have four sides and we want to create a logic symbol to represent this, a logical sentence to represent this, we first need to write it as a conditional sentence. So we might say, if a shape is a square, then it has four sides. Now what we can do is we can find the simple statements within here. So we have a shape being a square and we have a shape having four sides. So we're going to label each of those. When I label my variables when I'm going from English sentences, I usually use something that's kind of representative in the sentence. So like, since we're talking about a square here, I might say that I'm going to use S to represent the shape is a square. If you want to use P and Q, that's obviously fine. It's just very important that we label our variables and we have them there so that way everyone knows what we're talking about here. And then I might use F to represent that a shape has four sides. Then we would rewrite this in symbols using if S, then F. So for all squares have four sides, we would need to use the if-then form. If a shape is a square, then it has four sides. That would be if S, then F. Okay, a little more about turning sentences into symbols. So here are some helpful steps for determining the validity of an argument. As I mentioned, we want to identify all simple statements. And if we need to take that universal quantifier and rewrite it, we might need to do that. So that way we can figure out what these simple statements are within that sentence. The simple statement should not have negations. So if it says, today is not cloudy, the simple statement would be, today is cloudy. And then that would just be the negation of it. And we want to label them appropriately. That's either using P or Q or using things that kind of represent what we see in the sentence. So today is cloudy, we might use C for cloudy. Then what we do is we rewrite each premise and the conclusion in symbols and set it up similar to an addition problem. So we saw this before in the logic. When we just had the logic symbols, we would have our first line, so if P then Q, then we would have the next piece, so we'll say P or Q, and then if we only have two premises, we would say therefore, so we just set it up using this like equal bar, and then we would have our conclusion, and our conclusion in our made-up example will be not P and Q. So look, we would want to set it up something like that. Once we have that set up, we can figure out what the truth table needs, how many rows do we need based on the number of simple statements, and how many columns do we need based on all the information. So right, we need one column for each simple statement, any negations, any premises, the conjunction of the premises, and then the final column is always the conjunction of the premises, therefore the conclusion. It's a conditional statement, but we call it an implication when it's like the big argument ender. And then we determine if the argument is valid. Remember, for an argument to be valid, that final column has to be all trues. We need a tautology at the end. So let's decide whether this argument is valid or not. If it rains, then I will watch the Simpsons marathon. I did not watch the Simpsons marathon, therefore it did not rain. Okay, so first we need to figure out the simple sentences here. So we have it rains is one simple statement, and I watch the Simpsons marathon would be another simple statement. So identify and label the simple statements. I'm going to say R for it rains and S for I watched the Simpsons marathon. Now from here, step 2, write the argument in symbols. So here we have premise 1. If it rains, so that would be R, then I will watch the Simpsons marathon. So if R, then S. Premise 2 is right here. I did not watch the Simpsons. That would be not S. Here's where I know I'm coming up on my conclusion. Therefore, And what happened? It did not rain, so not are. And I agree with myself, so that's good. So now it's written in symbols. Step 3, write the argument as a conditional statement. So that's just taking premise 1 and premise 2, therefore the conclusion down here. So it would read, if R then S and not S, then not R. So we would want to make sure it's set up like that. And then lastly, our truth table. So for our truth table, let's see what we need. We have 2 simple statements, right? We had R and S, so we're going to need 4 rows below the headers. And for the columns, we need 1 column for R, 1 for S, 1 for not R, 1 for not S. Here's premise 1, we need 1 for premise 1. We already have premise 2, and we already have the conclusion, so then we would need a conjunction of the premises and the conjunction implying the conclusion. So it looks like we're going to need 7 columns. Hopefully I set up my 7 columns. Looks like I did. Yay! And we already have R and S. I need not R, not S. I need premise 1, if R, then S. I need the conjunction of the premises, so I can say P1 and P2, or I can write it out. If R, then S, and not S. Then this one here is going to be premise 1 and premise 2, implies the conclusion. So that would be if R, then S, and not S, therefore not R. And I'm just going to label my things here. So here's premise 1 right here. Here is premise 2, and here is my conclusion. And now to get started, R is going to have, I'm going to put true, true, false, false. And then for S, I'm going to alternate true, false, right? We can't do true, true, false, false again, because then we would only have 2 of the 4 combinations of trues and falses for R and S. Not R has the opposite truth value of R, so it's going to be false, false, true, true. Not S will have the opposite truth value of S, so we're going to alternate false, true. If R, then S. So this is a conditional statement. Remember, for a conditional statement to be true, either the hypothesis R is false or the conclusion S is true. So here we have if true, then true. That's good. Here we have if true, then false. That's no good. Here we have if false. That's going to be a true conditional. And if false will be a true conditional. So we end up with true, false, true, true for premise 1. Now for the conjunction of the premises. So here we're looking at, this is a conjunction. We need them both to be true in order for the conjunction to be true. So we have premise 1 and premise 2. Whoops, true and false is not, that's false. Here we have false and true, that's false. True and false is false again. True and true, hey, we finally have a true. Okay, and now, do the premises necessarily imply the conclusion? That's what we have to look at now. So either we have an F in this column, or we have a T in this column, or both. And I'm going to highlight them just so that they're a little bit easier to see. So here I go highlighting. This is my hypothesis. I'm going to put an H there. And this is my overall conclusion right here. So we have if false, that's fine. That's true. Yay. If false, that's true. If false, that's true. Last one, if true, oh, we have to check the conclusion here. If true, then true. And we have all trues, which means what? The argument is valid. We have a valid argument because our final implication ended up being a tautology. We ended up with all trues in that final column. Yay, valid, woohoo. Okay, in our next example, either I did not study or I passed the exam. I did not study, therefore I did not pass the exam. I encourage you pause the video, try the 4 steps, see if you can turn this into symbols, set up your truth table, decide whether this argument is valid or not. Okay, so step 1, we need to come up with our simple statements. So we have here, now remember we don't use negations in our simple statements. So the one simple statement will be I studied, which I might use S for. And what's the other one? I passed the exam. So S, I studied for the exam. P, I passed the exam. That's what I'm going to use. You can use whatever you want as long as you're consistent. Step 2, we need to turn this into symbols. So for this to be simple, so either I did not study, so that would be not S, or, that's a disjunction, or I passed the exam. Okay, that's premise 1. Premise 2 says I did not study. Did not study. Then therefore, our conclusion's coming up. We're going to do our triple dots. Therefore, I did not pass the exam. not P. So this would be step 2 right here, setting it up. Step 3, we want to write this as that final implication. So we would say not S, sorry, I'm getting carried away here, not S or P, and not S implies not P. Then we want to set up our truth table. So for this truth table, we have 2 simple statements, which means we need 4 rows. And then how many columns do we need? We need 1 for S, 1 for P. We need negations for both. We need premise 1. We already have premise 2, we already have the conclusion. We need the conjunction of the premises and then that final implication. So it looks like we're going to again need 7 rows. Okay, let's get this set up. We have S, P, not S, not P, not S or P, not S or P, and not S. And then our final implication here, not S or P, and not S implies not P. So here's our conclusion. Oh, sorry. That's the final thing. That's our argument. Here is premise 1 and premise 2. Oh, that's what I was going to write. I was going to say premise 1 and premise 2 implies our conclusion. This is premise 1. Here's premise, that's the conclusion, sorry. Conclusion, and then here we have premise 2. Okay, so we're going to start off by filling in our simple statements with true, true, false, false, true, false, true, false. Then not S, we're going to just negate S, so it's going to be the opposite of P. Okay, for premise 1, we have not S or P. In order for a disjunction to be true, we need at least one true. So either not S is true, or P is true, or they're both true. So we have false or true, that's true. False or false is false. True or true is true. True or false is true. Now the conjunction of the premises. So we're looking at this column here and this column here. This is a conjunction, so we need them both to be true. So we have true and false. Whoops. Well, that's not good. False and false. Ugh. True and true. Hey, true and true. Okay, and then our final column, we have our hypothesis right here. We have our conclusion over here. I'm going to highlight them. So highlighting the hypothesis and highlighting the conclusion. And remember, this is a conditional, so we need either the hypothesis to be false or the conclusion to be true, or both. So if false is by default true. If false is by default true, here we have to check it. If true, then false, that's a false. If true, then true is a true. So is this argument valid or not? It is not, because we have that one false in that final column, so this argument is invalid, not a valid argument. And if we think about it, let's look at what this says. I did not study or I passed. I did not study, therefore I passed. Now, is it possible that you could have passed even if you didn't study? Well, yeah, if the test was really easy, right? We've talked about that before, that's totally possible. So it makes sense that this argument is invalid. One more example. In this last example, I encourage you pause the video and try it on your own. Okay, how'd you do? Well, we have a problem right here, because right here we have that universal quantifier every time I hit the snooze button. So the first thing we need to do before we talk about the simple statements is we need to rewrite this as a conditional. And so this as a conditional would be if I hit the snooze button, then I will get 10 more minutes of sleep, or then I get 10 more minutes of sleep. So the first thing we need to do is take that first sentence, our first premise, this is now premise 1, and turn it into a conditional. Once we've done that, now we can identify the simple statements. So there's one right here, I hit the snooze button. There's one right here, I get 10 more minutes of sleep. And then we actually have a third one, I missed the bus. I chose to use S, T, and B. Did you have to use those same variables? Absolutely not. Those were just the ones that I chose. Okay, from here we need to build the argument. So we have premise 1 I labeled here. That would be S implies T. Premise 2 is up here. I get 10 more minutes of sleep or I miss the bus. So that would be 10 minutes of sleep or I miss the bus. Then premise 3 is right here. I missed the bus. This happened. Therefore, I hit the snooze button. What's my snooze button? S. So here's our argument right here. And now we want to think about it as what's that final column going to be? That final column I'm going to put all the way up here because I'm running out of space. We're going to say, this one has a triple thing, right? There's 3 premises. So we have this and this imply that. So that's our final argument. That's going to be our final column. Now we need to decide how many rows and how many columns do we need. Well, because we have 3 simple statements this time, we're going to need 8 rows below the headers. 8 rows below the headers. How many columns will we need? Well, we need 1 for each of the 3. So 1, 2, 3. How many negations? No negations. Great. We need 1 for premise 1. We need 1 for premise 2. We need 1 for the conjunction, and then 1 for that final implication. So it looks like, again, very consistent here. We're going to need 7 columns. And it's not always the case that we need 7 columns. That's just how it panned out right here. Okay, so first we need S, T, B. Then we're going to need premise 1, S, then T. Premise 2, T or B. We already have premise 3. Now we need the conjunction of the premises. I'm not sure I'm going to be able to squeeze this in. I'm going to try. So we have S, then T, and T or B, and B. Oh, I got it. And then our final column, we're going to have S, then T, and T or B, and B implies S. Just labeling these, this is premise 1 and premise 2 and premise 3. So this might be the first time in any video that we've looked at a triple, right? We've never had to look at a triple before. Now we're going to have to look at 3 columns at the same time. Can you handle it? I hope so. This was premise 2, this was premise 1, premise 3, and our conclusion. Okay, so now we want to fill in the simple statements. So when I have 3 simple statements, I do 4 trues followed by 4 falses for the first one. For the second one, I do 2 and 2, so 2 trues, 2 falses, 2 trues, 2 falses, and then I alternate true, false, true, false. So this gives me the 8 possible combinations of trues and falses for the 3 simple statements, right? We need to have 8 unique things, orderings in those 3 columns. Okay, now premise 1, if S then T. So in order for this to be true, either the hypothesis is false or the conclusion is true, or both. So we have if true, then true, that's good. If true, then true, that's good. If true, then false, that's bad. If true, then false is bad. Then we have 4 false hypotheses, so all of these are going to be trues. Makes that conditional statement true. Okay, T or B. So in order for this disjunction to be true, one of them needs to be true or both. True or true is true. True or false is true. False or true is true. False or false, nope, false. True or true is true. True or false is true. False or true is true. False or false is false. Now we have the conjunction of the 3 premises. The good news is that they're all right next to each other, so I don't think I need to highlight or anything because they're all just, we've got bing, bing, bing. And again, this is a conjunction. In order for this conjunction to be true, all 3 statements have to be true. Oh, which we see in the very first row, true, and true, and true, that's true. Then we have a false and true, that's going to be false because of that false. True, false, true is false. A whole line of falses is false. Then we've got a triple true, so that's good. False, true, true is false. True, true, true is true. And false, true, false is false. Okay, and then for our final implication, we need the conjunction of the premises as our hypothesis and the conclusion as our conclusion. So I'm going to highlight them just so that way it's nice and clear. Oh, it just goes way back to the beginning. Oh, that's nice. And remember what we're looking for here. We either need a false hypothesis here or a true conclusion, or both. So we have if true, then true, that's good, that's true. If false, that's automatically true. If false is automatically true. If false is automatically true. Here's another one we have to check. If true, then false. Wah, wah. If false means true. If true, then false, there's another false. And if false means true. So because of the falses, we only needed 1, but we had 2 for reinforcement. This argument is invalid. Invalid argument. Sad day. This has been examples of arguments going from sentences and determining whether they are valid or not. Thank you for stopping by.